¿Y tienes idea para resolver este?
Sí.
Ok. Bueno, O es el vértice. El centro del círculo. Ok. Ok. Good.
25 degrees.
25 degrees. Ok. How do you solve it? ¿Cómo lo resolviste?
So, um, so the angle's 37 degrees, 28 degrees, and X, are all, mm, um,
Describe.
inscribed angles.
Yes.
Um,
Describe. So this is
the section,
so this arc is 56. This will be 74. Or you made it some other way.
lo hice así.
¿Sí? ¿Sí lo hiciste así? Ok. Bueno. Y entonces este es 180 menos 130, ¿no? Porque es 50. Y vamos a tener aquí 25. Ok. That's right. Sí, fue esa tu respuesta,
Sí.
¿verdad? Ok. Ok. Muy bien. El problema 4.
50 degrees.
Let me see. How do you solve it? What do you do?
So, um, so, if x, um, if x, is symmetric, um, by, um, the origin of the circle, um, to the point and the intersection between, the lines on the circle, then, the line from the intersection um, of the two lines, um, and the point, um, on the circle, um, which is in the middle of the angle X, um, then that line, goes through the origin. So, um, uh, so, um, the top and the bottom, um, triangles, um, uh, have 90-degree angles, um, because, the line goes through the origin. So because of that, if we take one of them, say the bottom, um, then, um, the the angle is 90 degrees. Since the, um, angles of a right triangle add up to 180 degrees, x is 50.
Oh, this is okay. That's right. Let me see. Let me see. Okay. This is symmetrical. Okay. This is 90 degrees. This will be 50. This will be, I don't know. This is just, esto es 180, ¿no? All this, it's 180. We have here 130. We have here 65. Here we will have 25. And also here we have 25. Okay. Okay. Let's see. Do you know what is the name of a quadrilateral like this that has all his vertices so in the circle?
A cyclic, a cyclic quadrilateral.
Okay, that's cycle. Okay, cyclic quadrilateral. So this must be 180 minus x. No matter if this is symmetrical or not. Okay, so this is also 180 minus x. Okay, so let me see. The fastest way for solving this is the way in which you do it. Okay. Well, there is a. We're going to see one theorem. Okay. If we have something like this, we want this angle. This is A, this is B, this is C. We will have that this is A plus B plus C. Why? This is, that's right. Is that right? Yes, that's right. Okay. If this is X, this will be, let me see. This is X. So this is 360 minus X. Yes?
Okay.
Okay. And we know that if we add A plus B plus C plus 360 minus X will be equal to 360. ¿Ok? Si sumamos estos cuatro triángulos deben ser 360 grados. Because this quadrilateral can be split this way. Okay? We have two triangles. Yes?
Okay.
So if we subtract 360 from both sides, we will have A plus B plus C, and we can add X from both sides. So we will have this. Yes. So X is equal to A plus B plus C. Okay. I don't know if this will be important in this problem, but it's a nice theorem. Let me see. This will be 180 minus X, because every cyclic quadrilateral must be this must if we add the angles, the opposite angles of a cyclic quadrilateral, we will have that they add 180. Okay, this is also 180 minus X. Do you agree? If we use this, 180 minus X will be equal to 40 X. Okay, it's the theorem that we use. See, so we will have this will be 180 minus 40 be equal to 2X. So 100 will be equal to 2X. 50 will be equal to X. That is the answer that you give. Okay. Okay, let's see then. Let's see the next. Do you understand this problem?
Okay.
Okay. Good. Do you have ideas for this? ¿Tienes idea de este, Sebastián?
No.
Okay, let's see. Then, let me see. Estoy haciendo el dibujo. I am making the drawing, but I think that it will be useful if you see it. Okay. Here we will have um, the distance from A to C will be 18. Okay. Let me draw something like this. 18. Okay. And here it says that the figure ABC, it's made from a semicircumference. This is a half circle. We will have something like this. This is easy to calculate. Okay. Here we will have that. First, we are going to, okay, let me see. Let's make all the drawing. This is a semicircle, okay? And here, this is a quarter of a circumference. It's very important that we find the centers of the circle. This center, this will be 9, okay? This is easy. But we also need the center of this circle. How can we find the center of this? We need here a line. It will be perpendicular. And here we need 45 degrees and 45 degrees. Do you agree? Because,
Okay.
okay, yes. If we want to draw this,
So
it's useful. Okay. This is perpendicular. In it here. And because we will have a quarter, we need 90 degrees. We want 45 and 45. So we can draw something like this. It's useful to think, okay, what are the lines that we need? Es muy útil pensar qué líneas necesitamos para construir la figura. For example, this of the circle, we will need this line and this line. Okay? Then we are going to draw this. An arc from here. No, an arc from this is the center and this is the arc. Yes. So if we want to know this, we need to find half circle and we need to subtract this. Okay? Do you understand this idea?
Sí.
Muy bien, vamos haciendo los cálculos. Okay. Let me see. First, we want this. Okay? And this is very easy because we have here 9. So this will be 1/2. We have here half of a circle. So 2 5 times 5 por radio al cuadrado. 5 times 9 squared divided by 2. Okay, that's me. Okay. There. Yes. And now we need to subtract. Need to subtract this part. So if this is 9 and this is 9, this will be 9 times the square root of 2. Okay?
Sí.
So we need a quarter of this circle. Mm. Yes. Pi por radio al cuadrado entre 4 minus this triangle. That is 18.
It's 9 squared.
Yes, it's 9 squared. I'm going to I was to write this. It's 9 squared. Okay. So this is a 1 times 2 pi minus 9 squared. Okay. 9 squared. So we need to subtract. Let me see what's happening here with my. Ok, esa parte sí queda clara. Ya nada más hay que hacer la resta. Necesitamos restarle. A ver, déjame ver, se va a apagar mi pantalla un momento. Perdón. I can see another screen. Yeah. Ya está, perdón. Ok, entonces teníamos que el área del círculo es mm, eh, pi por radio al cuadrado, la mitad. Ok, 9 squared pi divided by 2. Okay, and the other one will be, we need this. So this is 9, this is also 9.
Sí.
And this is 9, the square root of 2. So it's pi times 9 squared divided by 4. Yes. Minus 9 squared. 9 squared. Okay. That's right. Ok. Y esto es 9 squared pi 2 times 2 divided by 4 minus 9 squared. So if we simplify this, we will have pi 9 squared divided by 2 minus pi 9 squared divided by 2 plus 9 squared. So this will be 81. Okay. See, Sebastian?
Sí.
Okay. Here we need to only need to know how to build the figure. We need to find what we are going to subtract. Okay? Okay, let's see the next one. This one. Those problem those problems are from a contest called IMC, International Mathematical Contest. There are two IMC in the world, and this is in Asia. And sometimes they ask that we use 22 divided by 7 instead of the exact value of pi. This is the value that the Greeks used. Este era el valor que usaban los griegos para pi, 22 séptimos. Cuando nos piden hacer esto en un problema, usar 22 séptimos, pues lo que va a pasar es que vamos a tener un... vamos quiere decir que algo se va a cancelar y va a ser nos va a ayudar bastante. So again, we need to find what we are going to subtract. Let's see. Here we have 42. Here we have 56. So, ¿sí tienes ideas para este, Sebastián? ¿Tienes ideas para este?
No.
Ok, let's see. Vamos a ver cómo está construida la figura. Dice, la figura está formada por un semicírculo, un cuadrante y un triángulo rectángulo. ¿Sí? Un cuadrante it's a quarter of a circle. Okay. Entonces, vamos a ver. It's a quarter of a circle. This is a triangle, and this is a semicircle. Let's see. First, we need to see all the figure. We are going to have this a triangle plus a semicircle. Okay? Un cuadrado y un semicírculo, ¿de acuerdo? And we are going to subtract this. So we need to add the triangle plus the semicircle, and we are going to subtract quarter of a circle. Do you agree with this?
Same.
Okay. Let's see. First, we are going to find this. 56. It's 56 times 42. Divided by 2. Okay. Now, the semicircle. Do you find something special about this triangle?
Um, it's a right triangle.
Yes, but we can use Pythagorean theorem. The Pythagorean theorem. But it's this is 7 times 6. 7 times 8. Okay, this is 40 times 3 and 40 times 4. Yes?
Mm.
It's a very special triangle. Es una terna pitagórica. It's a Pythagorean triplet. It's the triangle 3, 4,
5.
3, 4, 5. So this is 5 times 14. We can do all the Pythagorean theorem. Okay. This is 70. So the semicircle will be pi. What is pi? Okay, here we are saying that we are going to use 22 divided by 7. Okay. 22 divided by 7 times pi times 35 squared divided by 2 pi por radio al cuadrado entre 2. Okay. This is the semicircle. Okay. And we need to subtract this over. What is the area of this one?
Of the quarter of a circle.
Yes. It's
Mm,
pi.
it's it's pi times 42 squared divided by 4. But since 42 is divisible by 2, um
Yes.
it can be rewritten as pi times 21 squared.
Yes. Okay. We're going to simplify this with this. Okay, let's see. Hey, no, that's not what I want. Okay. And we can 20 times squared, it's 40. 441. Okay. We can divide. Okay, let's see. Quiero hacer esto. This will be, we're going to add to, divide this. Okay, this is 20 times divided by 7 times, you said this is 21, and that's all. Okay?
Okay.
Yeah. Here we can have 11 times 35 times 5. Yes? We are going to simplify 1/7 from this. 7%. 7%. Okay. And this will be
Okay.
56 times 21. Okay. And we can simplify this.
Yes.
This will be 7 times 7. Okay. 11, 22, 735. Okay, this is 11 times 7 times 5 times 5 minus 11 times 2 times 7 times 7 times 3. We have this common. 11 times 7 times 25 minus 42. That's right. This will be 11 times 7 minus 17, I think, plus 7 times 8 times 7 times 3. There's nothing special about those numbers. Okay, we only need to do this.
We can factor out 7.
Only 7.
Yeah.
Okay. 8 times 7 times 3 minus 70 times 7. Okay. 21 por 8. 8 por 2, 1668. Menos 17 por 7. 7, 49, ya no son 7, 8. 89. 899. I think that this is
Right.
iron balls.
I you didn't you say 7 times 8 times 7 times 3 minus 17 times 7, but it should be 17 times 11.
Yes, that's right. Okay, that's right. 20 times 11. Okay. It's also De todos modos, no nos ahorra trabajo. O sea, hagamos la operación ya. Ok. 21 por 8, 178 menos. Oh, this is not right. Because this is negative.
Yeah.
Um, we made something wrong. Okay, let's start again. 50, 56 times 42 divided by 2. Okay, this is right. And this is 35. 5 por 14, 14 por 4, 14 por 3. 35 squared times pi divided by 2. This will be 42 squared times pi divided by 4. Okay. 56 times 21. This will be 11. 35 times 5. This is 22. 21. This is the problem. 22. Okay. This is 21, 21, because we have divided this. So 3 times 21.
3? Oh, okay.
Yes, no, 21, 21
Um,
divided by 7. 3 times 21. So we only need to do the math. Solo necesitamos hacer la cuenta. Let me write this. Okay. 56 times 42 divided by 2. Okay. Plus uh, pi times 35 squared. Oh, no. Pi por radio squared. Pi por radio al cuadrado entre 2. This is divided by 2. Entre 2. Minus the quarter. It's 22 divided by 7 times 42 squared divided by 5. 42 squared divided by 4. Okay, we already said that this is 25, 56 times 21. We can simplify this with this. We have 11. And here we will have, I don't know, we can do this. Okay.
you need to split the 35 squared.
Yes. Okay, 175. It's 5 por 3, 15. Okay, this is right. Here we will have, 22 times 63. Okay. Um, here we will have this. This is this. This. Um, okay. 7 por 7. 7 por 7. This is 49 times. Um, yes, that's right. 7 por 8 y 7 por 3. 24 menos 11 es 40. 40 times 10. 30.
Sí.
Okay. Okay. Yeah, that's it. Okay. That's the answer. Okay. The important part, well, doing the right, um, finding the right answer for every one of this, it's important, but the most important part is we can, we need to understand how the figure is made. Okay. Lo más
Sí.
importante es encontrar cómo se forma la figura. Ok, son las 4. ¿Quieres que hagamos uno más?
Okay.
Ok. Okay. Semicircle. Center and field. Un rayo de luz abandona el punto M. Here. And here. Here. Rebota en el semicírculo de que el ángulo MCO it's equal to OCB. Okay. Let's see. COM. We need this. Okay. Let me see. Let's see. We will have this. We will have this. It says, rebota en el semicírculo de manera que MCO, this angle, is, okay. Let's see. This will be equal to this. Rebota en el semicírculo en C de manera que este ángulo es igual a este. This alpha, this is also will be alpha. MC. Oh, yeah. Y entonces rebota en el semicírculo de la misma manera. I suppose that the same way means that this will be equal to this. Okay, this is beta y beta. And we need to find this. Okay, let's see. Mm, okay. Ah, am, ¿Ya viste cuál es la situación en este?
Sí.
¿Ya viste cómo? Okay. We are going to forward alpha and beta. This is equal to this and this. So this must be, this is also alpha. You can see why?
Sí.
Okay.
What's that?
And because this is equal to this must be also alpha. Because we have an isosceles triangle. This must be equal to this. And this is alpha, and this is also alpha. And we know that this figure has 1, 2, 3, 4 sides. It's a quadrilateral. So we need 10, 90 plus 4 alpha will be 360. 5 alpha, 5 alpha. Yes. 1, 2, 3, 4, 5. And alpha will be 60 divided by 5. This is the same thing. Yes. If this is
Mm.
54, this will be 36. Okay. Listo. Ok. Le envié el libro que estábamos trabajando la vez anterior a tus papás para que lo imprimieran si querías practicar con aquel libro de geometría. ¿Sí? Entonces, por hoy terminamos, Sebastián. Si quieres practicar, tus papás ya tienen el libro de la sesión anterior y después seguimos con estos problemas. ¿Ok? Ok. Creo que por hoy terminamos. Que
Oh.
tengas bonita tarde. Hasta luego. Listo, hijo.